Okay, our Kubernetes is going to be in four parts. First part, we will cover all the Kubernetes component. Second part, we will look into the config file. Okay, what are the config files in the Kubernetes? And third, we will look into the commands of the Kubernetes. And fourth part will contain a project which will include all these three parts. So in
Oh,
this way, we will get into the deeper section. Since we already covered the Kubernetes architecture, so we will not go back into it, but somewhat we will cover it while going through all these components and all the parts. Let's start with the K8 components. K8 is another short name of Kubernetes. Okay. When I say component, it means the most used component in the organization. Well, Kubernetes having a lot of components. Component basically the parts, okay, on which the Kubernetes is relying that everyone should know. And most uh, known components in the organization will cover only those main one. Okay, let's start. So we looked into the services when we were dealing in in our previous class, but let's look it back in. Okay, what is the main use of services? So do you remember service YAML file we created? Okay,
yes.
that's a config file. So what was the main job? The first main job was to provide the permanent IP address to what? To our node. Okay, suppose in our node there is two pod. Okay, and these two pod need to interconnect or need to talk to each other. So they'll be getting a unique IP address for each pod. Each pod will be containing a unique IP addresses with which they will communicate with each other. And life cycle of a pod and services are not connected, which means if one of the pod got destroyed, it will be replaced by another pod, and that pod will be having another IP addresses. Okay.
Okay.
Now, what happens? So that's service. That's one of the component of your Kubernetes, which main task is to provide the IP address to the pods for their communication purpose. Now, there is one more part which we will cover later, but for now, the main job is this one. The second task is the second component is like whatever we do in our pods. Okay, it should be accessible. Our main job is to accessible, make our application, that is my app, accessible to the people. Okay, which is an external service, right? We
Yes.
use this URL, but this is a vague URL. Okay, so there is two type of service. The external service is the pod which we want to make it live and other customer can see it. There is an internal service. Internal service, I don't want my database to be visible to the people. So I will use some internal service on this one, external service on this one. That's our main job. Okay, we have to look into what are the pods or the application pods we have to make it live, and what are the pods we have to make it private. So if you look into this external service, my app service colon IP address colon port. So this is the general one. If I go to the specific one, it will look like this. So this is the IP address of your pod along with the port number on which it will be running. Okay. And this will be open to all the people. Okay, whom share basically your internet right now. But in general, do you want your application to be accessed like this or to be accessed like this? Which one? For the customer?
Second.
Second one. Because
Mm.
people want their application to be accessible using their domain name. So it
Mm.
should be accessible like this instead of giving the port number or the IP address like this.
Yes.
So there comes another service into the picture, and that service name is Ingress. So Ingress job is to convert your this service, your
Mm.
external service, into a readable format or into a simplest format and make it live to the customer. Now, there was a one question I have been asked it in my long debate previous interview question that how will you make your Kubernetes pod live to the customer using which component? So the answer was Ingress. Understood? What is the job of service? What is the job of Ingress?
Yes.
Third service, we look is this one. We have this my application, okay, which also running MongoDB service, one of the service name as MongoDB, okay, which is a database service. Now, what do you want? That database URL usually built in the application. Now, what happened? When you will create this my app pod, this URL of your database must be available over here also. Okay. Suppose by the name of MongoDB service.
Mm.
So this type of URL is available in your application also for the connection purpose with your database. Now in future you went and you changed to my MongoDB service to only MongoDB like this. You changed something into that one. So what happened? What you have to do after that? You have to rebuild your project again, push this change into the repository, pull it in your pod, then only it will be visible and then only it will available to the customer. The connection will happen. So any changes if you do in the service file, it will lead to these many tasks. You have to do it again and again. And in general, people do a lot of changes. So it's a hectic process. Again, rebuild, push it to the repo, pull it to the pod. So it's a hectic process. And there comes your config map into the picture. That is the third component. Okay. So basically, what do we keep in config map? All the configuration related to our app will be stored over here. So no need to change anything in the application or the database. You just do it over here and run it. It will reflect back to the pod. No need to push it or anything. Do it. Okay. If database URL is like this, you can directly go and change it. So external configuration of your application. All this component we will look when we will do the project. Okay. So the third component is the config map. Config map basically contain all the configurations. Okay. Whatever the configuration required for your application. That's the third one. So for validation purpose, we also use MongoDB user and MongoDB password. These all things we cannot keep in our application. We have to create a config map and then we have to put that in our application. So this config map will store all these things. Your password, username, database, URL, everything.
Mm.
Even these secrets also. A lot of this. So these secrets are actually stored in base 64 encoded, which means if your password is Sujata123, so it will not be stored as Sujata123. You have to encrypt that one in base 64 encoded, which we will do. I will show you how to do it, how to encrypt your
Okay.
password. So on behalf of your password, a readable password, it will give you some generated number. Okay, that number you have to store over here so that no one in the future also come to know. The built-in security mechanism is not enabled by default. So basically you have to do all these things. Used to store base 64 encoded. This part you have to do by yourself. Kubernetes not will do you on behalf of you. Okay. So so this is the another service, basically the secrets. We looked into the config map, which contain all the configuration, and secret will contain all your password and all. So we looked into the pod, the simplest form, service, ingress, config map, and secret. These five components. So far, if you have any confusion, you can ask me.
Mm.
All clear?
Yes.
Pod is the smallest one, okay, which I have not covered in this lecture, but in the previous we covered. So
Yeah, I saw.
in a
Mm,
simple way, I have to say what is pod. So pod is the simplest known component which stores your container, okay,
mm.
and that's the simplest one. In Docker, you have the simplest component is the container. In Kubernetes, you have the simplest component is the
But
simplest and the smallest is the pod. Service
mm,
file help you to generate the IP address and assign to the unique pods. Okay, Ingress will help your application to make it live to the customer. ConfigMap
mm,
store all the configuration, whereas secret store all the password and all the secret related to your application. Okay. Now let's see into the volume, which is very important. We looked into Kubernetes volume, sorry, Docker volume as well, which main task was if container got destroyed or if container somehow by any chance stopped running or not working. So what will happen to the volume? Means if I can created Jenkins. Okay, remember we created Jenkins on one of the container and then we
mm,
stop that container, we remove that container and we try to access the same Jenkins from the other container, right?
yes.
In the same way, you have a Docker volume. So suppose if your applications database are stored in the pod and somehow the pod got destroyed. Okay, so what will happen to that one? Your whole database will be gone,
Yes.
right?
Mm,
So for that, you need to have a volume connected to it. So what happens? We do not configure volume separately. Kubernetes does it for us. We just have to tell which volume it has to use. Either the local volume means your own CPU data volume, okay, or the remote or cloud volume, okay. You can assign to the cloud as well, or on-premise volume. So you just have to tell which volume to be used, okay, and it will use that volume and keep your data persist. Got it?
yes.
One more question could be asked that how will you ensure that your application, even though your application is using the volume, but still suppose my application somehow crashed, this pod somehow got crashed. So how will you handle this situation?
To the volume.
So basically, you create replicas. Okay.
Mm,
So replica sets should be available like 3, 4, 5 type of replica. So that whenever one pod got destroyed, you can suddenly create the other replica.
okay.
And do you remember which component extra we use for this replica set? In the last class, we covered two components. One was service, other was
Master. Master.
no, other was deployment.
Yeah, okay.
So in deployment, we mention all the how much replica set you want, how much
Mm,
replicas you want. We will look into that.
okay.
So understood the volume part. Okay.
Yes.
So either the volume will be used your local or the remote volume. But there is a catch. Okay. Like using the replicas, we are controlling as well. So that whenever one pod got destroyed, other pod will be replacing it. Okay. K8 does not manage the data persistent. Okay, it does not have its own storage part, though it has a storage part, but not using for the pod storage, pod data storage. For that, you need to provide your local data access. K8 has one master. In master node, they have etcd. Remember during the
Yes.
architecture we were covering etcd. So that
Yes.
one stores some amount of data, and what type of data we will look into that one as well.
Mm,
Okay. So this what says that if your service pod got destroyed or can't be reached by the user, what will happen? Your functionality will affected. So for
mm,
that case, you need to replace that pod with the another replica, right?
yes.
So service has two functions. Remember service YAML file? We covered in the beginning, that
Hmm.
first job was to assign the IP address. Second job is the load balancer.
Yes.
Now suppose one pod can handle up to a certain limit of user, right? But if suddenly thousands of more user comes, what it will do? It will separate the user customer, okay, load balance it, and by divide the customer. So half of the customer suppose will be available in this pod, and half of the customer will be seeing my application from here. So it certainly reduce the load on your application or on your pod. Okay.
Yes.
So service YAML file has two functions. First is to provide the IP address.
Hmm.
Second is the load balancer.
Hmm.
Okay. Okay. Now the question was, if somehow by any chance this one got not in use or unable to reach, this pod got destroyed. So the
Hmm.
blueprint part of this pod is actually stored by this deployment service. Okay.
Yes.
So this deployment part will store the blueprint, also create the replicas. In the previous class, we looked into the deployment YAML file and service YAML file. Service YAML file having two jobs, providing the IP address and the load balance. But
Hmm.
deployment YAML file is the one who is responsible for creating the pod. Remember, pod we do not create it directly, we create it through deployment. First job is to create the pod. Second job is to create the replicas of that pod so that whenever any pod get destroyed, it will be replaced by the other pod. Okay,
Okay.
and that's the job of deployment. So this pod got destroyed, so it will be replaced by other pod.
Hmm.
Understood this part up till here? Any question?
No.
Now you may say, now I'll ask you the same question. What will happen to this pod if it got destroyed? Which component I'll be using to get it back?
Service YAML file.
No, not service. Service job is different. Service job is to provide the load balancing and IP address. There I'm saying this pod is getting destroyed, got destroyed. It's not
Hmm.
in work. So what, it has to be replaced by other pod, right?
Yes.
So which service we will use?
Deployment.
Deployment.
Hmm.
Now the question is, database is not like other applications. This application does not store memory, but database stores volume, stores memory, right?
Yes.
So you cannot generate deployment generally, or what? Deployment is not used for the database. Okay. See,
Okay.
DB can't be replicated via deployment. Your application backend frontend can be replicated, but database can't because it stores some amount of volume.
Hmm.
So to maintain, avoid the data inconsistency across all the, suppose I have five replicas, so five replicas should have the same type of volume. Why it is different? Because if any changes in your application, it will be stored in the your database, and not only this database, all the replica set of the database. So that's why it is different from the rest of the pods. And to avoid this inconsistency, for database type of stuff, we use stateful state. Very important question will be asked from this one. What is stateful state? What is the name of this, or what is the use of this component? Why
Hmm.
it is different from the deployment? Because deployment generally handle the application part. But when it comes to the volume, to handle my volume which is stored in the database, I used stateful state. Okay. What are some stateful apps? MongoDB, MySQL, Elastic IP, Elastic containers, or anything that is using the some amount of volume, having some data connection. Okay.
Okay.
Connection to the database. They will be, those apps will be a stateful app. So we will create this stateful state in our project.
Okay.
Great. So deployment for stateful stateless apps. Okay.
Hmm.
Stateless app means app which do not have any connection to database. Okay. No any relation with the this one. Not persisting in any volume and all. Just show the front end part or the back end part type of. So service deployment component will be used for such case. Stateful state component will be used for your database stuff. Okay.
Hmm.
So when you say stateful app means app which has some kind of a relation with the database. Okay. For example, MongoDB, SQL, PostgreSQL, GraphQL, lot of things like that. So how many components we looked so far? Can you remember? Recall it.
Deployment service.
Deployment, service, then
Pod.
pod, then
Ingress.
ingress, then config map and
Hmm.
secrets.
Yes.
Okay. Did we left any? Mm,
Hmm.
stateful, stateful set.
Okay.
Okay. So total 7 we looked so far.
Hmm.
Okay. But deploying a stateful state is not easy. It's very hectic compared to the deployment one. Okay. So database often take care of this hosted one. The thing is, you may get some help from the Kubernetes for deploying this part, but still it's very hectic task. Okay. So most of the people try not to go with the volume of data of Kubernetes. Rather, they try to this database do not store in the pod. They store it outside the pod. So if you store outside the pod, you do not require Kubernetes component. That is stateful state. Some organization does it because to reduce the complexity. And from outside, we will connect with our applications. So that's how it is happen. But if you are going to host your database in the pod, then you have to use stateful state.
Okay.
Okay. So, so now even if your whole node, this worker node get destroyed, you can replace it back with the other node because we'll be using stateful state and the deployment along with the service. So all three components will help us to recover our application. Got it?
Yes.
So just summarize it. Let's summarize it quickly. So we see in pod, basically the abstraction of the container, okay,
Hmm.
where we store the containers. We looked into the service for the communication purpose, that is the assigning the IP address. We looked into the ingress, which route the traffic into the cluster. Okay, whatever the customer will type, those those are the traffics will be routed to the cluster. Cluster means Kubernetes cluster. And Kubernetes cluster means Kubernetes master, Kubernetes nodes, okay, all this data. So its job is to provide that user URL on which the people or the traffic can come. Then we looked into the volume, okay. We looked into the config map and secrets, okay, and we also looked into the deployment and the stateful state.
Yes.
That's it. Any questions so far?
No.
Okay, great. So that's the first part of our Kubernetes, which is the Kubernetes components. So I'll just take